Good morning, everybody. Welcome to what will actually be the last of our Constructing Excellence seminars this year after quite a busy programme. Anybody who comes to our seminars regularly will be very familiar with the Government Strategy Construction 2025, and I'm sure you know all the sort of the challenges that puts on the industry. And the one we're particularly focusing on today is about lowering our costs, both the initial cost and cost in use. That's a challenge to get costs of our buildings and their whole life costs down by 33% by 2025. So I think this is a really good starting point for us today. This is all based on a piece of work that's been done by a team, which includes Andy Ross here, who's a chartered surveyor. He's currently working as a subject head of surveying at Liverpool John Moores. Bernadette Lord is commercial director of BIM, quantity surveyor with DSG Quantity Surveying, and Haniyeh here, Haniyeh Mohammadpourkarbasi, I think I got that right, is a low carbon quantity surveyor, and she joined BCM to look at really whole life costing and develop that for the company. She has a PhD in sustainable architecture and life cycle costing. I don't want to waste any more time talking, so I'm going to hand over to everybody now.
Okay, right, thanks Roger. Yeah, thanks for that introduction. Yeah, my name's Andy Ross, I work for John Moores University. Now I'm sure you've heard whole life costing, you've heard it before. It's been around since 1962, or perhaps 1958, which was a seminal publication by a guy called Stone, and since then the RICS, the CIOB have been involved in numerous presentations since. But we believe that we're now seeing a bit of a convergence, the convergence of organisational capability, that organisations have now realised that the technology is providing them with opportunities for unique ways of packaging what they've done in the past. We believe that past attempts have been a little bit crude and the information's not been very good, but that will improve as we start to collect more information via this Internet of Things and via the use of more integrated BIM approaches. We also believe there's some competitive advantage for those client-facing organisations who can start this early, and they've got something they can offer to the client, which is this provides a bit of additionality to what they've previously provided. And also, which is the important bit, is optioneering. What BIM is doing is allowing us to look at lots of different design options in a dynamic way that hasn't been used in the past. So the infrastructure around design modelling has changed, and the calculations behind it need to change at the same pace. So that's where we're heading towards. We're nowhere near there yet, but that's where our journey will definitely take us by 2025. We'll have more integrative modelling, and we're looking at this stuff here in the top right-hand corner, environmental analysis and life cycle costing. So in 10 years' time or 11 years' time, we would expect to be sitting with our clients doing lots of what-if scenarios and having more realistic options based on empirical data rather than just thinking of ideas in the future. So that's where we're heading. Now, to get there, it's not we can't rely on a software house to do it. We, as the industry, need to take some leadership here. Software houses will give us what we want, but we need to make sure that we've got the research, the applied research, in order to ensure that those software houses are building into their models the algorithms that we require. The KTP's a very quick run through, collaborative project between academia, industry, and the key person in this is the associate who actually delivers the project. And we're really lucky that we've got two great associates, Haniyeh, who's on the technical side, and Jackson, who you can see on the camera there, who's doing the marketing side. So those two associates, both postgrads, are managed by BCM and JMU to deliver the project. So where are we now? This is a work in progress, and we're reporting back on some interim results. Marketing, we're 9 months into the project. We're seeing massive benefits in terms of information capture within the organisation, marketing approaches, and also in terms of technological development. So that's me, I think. I'll now hand on to Bernadette, who will perhaps start to take us into whole life costing.
Thank you. Good morning, everybody. I'm Bernadette Lord from DSG Quantity Surveyors. I'm going to try and give you a bit of a overview of whole life costing and some of the difficulties stroke challenges that we face trying to predict the whole life costing of a building. Life cycle costing tends to deal with the construction, operation, maintenance and the end of life, the replacement strategy. In terms of things that impact the whole life costings that are difficult to predict, the externalities could be something like capital allowances, funding, some income that can come into it as well, and there's an element of non-construction cost there as well. So what is the purpose of whole life cycle? Well, it's to calculate the total cost of the building over its whole life. That includes your capital cost, your operational cost and any deconstruction of the building. So how do we go about calculating those? Well, the capital expenditure is relatively straightforward, isn't it? We usually get a project, we get appointed by a developer, there's a purpose for that building. We can get tendered, we can get the construction cost, the design fees, all the surveys, etc. The operational side of things is much more tricky because trying to predict the cost of the maintenance, replacement and the running costs of the building, that data is really, really difficult to obtain, and I know Haniyeh is going to talk a little bit about that in terms of where she got that information from, and we will discuss that later in the presentation. But to predict it is really quite tricky. Now the NRM3 is allowing us to give us a better insight into that moving forward, but we still have some way to go. And the deconstruction cost, well, that's predicted on historic data and just applying inflation, but again, is it in 30 years' time? How can we accurately predict inflation in 30 years' time from where we are now? So the robustness of the whole life cycle costing is always in question. So I think it's fair to say that building services is the single biggest contributor to the operational cost of a building. With the technology that we now have, it's much more transparent to see the M&E systems within a building. It's much more transparent to actually quantify those systems. And it's a little bit easier to value engineer because we've all been sat in design team meetings and we can't get the funding over the line, and it's let's change the frame from concrete to steel because the program is shorter and all that kind of stuff. But the actual impact on the running costs of that building are very, very rarely considered. But with the use of technology, we can now start looking and say, well, if you make that change, what impact does it have on the running cost of the building? Because that might dictate that actually I'll spend a bit more up front and I will save a significant amount of money running this building. The capital expenditure is still in the region of about 30% of the whole life cycle cost. Operational expenditure is around 65%, and I think Haniyeh's research actually kind of backs that up. But how do we try and convince clients to start looking at this? Well, it's very difficult because we have to look at the clients who have a big land bank. We have to look at the clients who want to look at sustainability design, who want to decrease their operational costs. So the public sector clients, universities, schools, those kind of things, those are the clients that we really need to start focusing and say, you know, come on, let's get on board here and let's try and do something about it. And that's me for now, and I'll see you shortly.
If I tell you for every £1 we are spending construction, we have to spend about £5 on operating and maintaining of that asset we build, and the business costs will be £200, and business outcomes will be £2,500, while design costs only 15 pence, then what will you base your decision making on to make the most profit out of your investment? It's your choice. It can be that £1, that £5 or £2,500, but I'm sure you all want to know the consequences of your choice. So that's why we are here to know about life cycle costs, I guess. Bernadette talked about life cycle costs in the whole building, so I I will just give an overview of where it all started and when and why, and focus mostly on the life cycle cost of M&E services. Then I will show you how we estimate the life cycle cost of building services using a very simple example of classroom and lighting. I selected lighting because I found it relatively easier building services component to understand compared to, I don't know, mechanical ventilation systems or heat pumps. So we go through the how to estimate life cycle cost of building services with lighting example. And then, as I mentioned, I will present the results of life cycle cost of a new build designed by BCM, and then hopefully after that you are ready to see the bigger picture and how we can use the option appraisal and payback time to select the right business case for our investments. Number of guides and methodologies has been developed and are available. In BCM, we are mainly use these three guides. British Standard 15686. It is on buildings and constructed assets, and issues guides on service life planning and life cycle costing. PD 156865 then is a supplement to this British Standard document, and it provides a standardized method of life cycle costing for construction procurement. The most recent one we are using is British Standard 8544, published in 2013, and it's a guide for life cycle costing of maintenance during the in-use phase of the building. So why detailed cost estimation and life cycle cost of building services? M&E expenditure contributes to approximately 40% of construction costs, so it is important to estimate these costs accurately. Also, building services play an important role on building energy efficiency and sustainability, and emphasis on sustainability and energy efficiency means it is important to justify the energy savings occur from the system you select, and it can also help workplace productivity, health and well-being. For one building services component, you can find various range of costs in different databases and sources. That's why governments are developing cost benchmarks for building services in the UK. For instance, BISRIA and BCIS are collecting cost of building services and components from different databases and providing references to benchmark the building services costs. Last, but the most important one is the short life expectancy of building services. How many times you replace your M&E components in the building during its lifetime. So that's why we should look at the replacement cost as well as the capital cost. For building services, and in BCM we consider these four elements to estimate the life cycle cost: construction cost, which is cost of M&E assets, and cost of installation and testing the system; operation cost, which is utilities cost of gas, electricity; maintenance cost, cyclical inspections required. They can be statutory or operational or just for safety reasons. And again, the most important one, replacement cost, which is the replacement of major systems and components. So let's see how we calculate each of these four elements. We start with construction cost. I guess we didn't have many quantity surveyors in the room, but those who are, correct me if I'm wrong. Quantity surveyors argue that as much as 80% of the time they need to spend on estimation is a spend on quantification. In BCM, we are developing detailed models of building services, which so the quantities can be taken off from the model, which is not only faster but also more accurate. We are using a response to cost the M&E assets, but aims of this KTP project is developing in-house cost estimation procedure in BCM. We are validating our costs by using manufacturers' data and contacting them to validate our costs. Also, we are using BCIS benchmarking system. So let's take a look at the results. I compared capital cost of fluorescent with LED. Again, not only I want to show you how to do it, I want to show you how important it is to consider the life cycle cost. You can see the capital cost of fluorescent for a typical school is about 42, 43 pound per square meter. To replace all the fluorescents in the classroom with LEDs, you need to spend 15% more at the construction stage. Looking at this, LED is not an attractive investment. So going to the next element, which is operational cost. Operational costs, as I mentioned, are energy costs. There are a number of ways to calculate them. We are all familiar with dynamic thermal simulation models, and this is how we get the energy demands and energy costs. So here you can see over 30 years of operating this classroom and running this classroom, you spend 49% less on LED than fluorescent. So now you might consider LED. The next cost is replacement cost. Here you can see the BCIS life expectancy estimation for fluorescent. They give you typical minimum and maximum life expectancy of the component. And how they do it is that they have carried out a survey based on the experience of building surveyors. So surveyors were asked for the typical range of life expectancies for the components. And the results is published in the BCIS running cost online subscription service. We have free access to this service due to our collaboration with Liverpool John Moores University. And you can see why I mentioned that replacement cost of M&E services is really important. You can see the replacement cost drops dramatically when you choose to go invest on LED rather than fluorescent. So the replacement cost of LED is about 76% less than fluorescent during 30 years of running this classroom, because you need to replace fluorescent every 3 years, but LED not sooner than 19 years, 15, 19 years. The other element of life cycle cost was maintenance cost. You can use CIPC Guide M to find out the frequency of inspections required for building services, or new rules of measurement which provide order of cost estimating and cost planning for building maintenance costs. Okay, so let's take a look at the life cycle cost of LED and fluorescent. I start with the pie charts. No matter you choose fluorescent or LED, the OPEX contributes greatly to the life cycle cost of both components. And looking at this graph, you can see after 30 years, you spend 40% less on LED compared to fluorescent. But you might say, I remember I had to spend 15% more to make this saving. So then this incurred cost will be recovered. So we compare the cash flow of LED and fluorescent and give you the payback time. For this case, the payback time is less than 1 year, because you save actually the money you spend at the capital stage by saving energy from LED. RIBA stages of design, life cycle cost procedure has different stages. Based on scope of your projects, your clients, you can choose different life cycle cost assessment methods. So if you are choosing between two components, or you don't know which funding option to go for, we will deliver different reports to you. Life cycle cost of the typical new built school. The school is 5,100 square meters, certified EPC rate of A, and it is occupied by more than 700 occupants. And the M&E design is done by BCM and it's located in Northwest. Here you can see the elemental life cycle cost plan of this new built school. You have comparison between the capital cost and operational cost of this school, and you can see the capex is 34% of the life cycle cost, while the opex is 66% of the opex in this example. The other graph, you can use this graph and analyze it based on your project and what you want to get from it. So you want to see which component and which building services has the highest life cycle cost. You can find out from this graph, which is lighting, or you can see that electrical and security services contribute most to the construction cost, and also energy cost. 51% of the energy cost in a school comes from the electrical components and services, and the highest lighting has the highest replacement cost. For this school, fluorescent lighting has been used. So let's see how this life cycle costing can help us to select the right business decisions. And also one of the requirements of construction 2025 was cost reduction by 33%. Let's see how we can achieve it. I look at replacing fluorescent with LED, and for renewables, again, I selected photovoltaic solar panels. As compared to other renewables, they are much simpler to understand, and we are all familiar with them. For PV, you have two options. I have compared two options. There are other funding options as well. Free PV, so your PV provider will pay for the panels, and you save the amount of energy generated by PVs. Or you can pay for your panels, and then government will help you to save more money by paying for the energy you use and also the energy you don't use. They give you the fixed tariff for your electricity prices for 20 years, which is lower than a standard electricity prices. And also, of course, you can save some money because you are powering your building with free energy. Comparing LED with fluorescent, you can see by spending 10% more on fluorescent, if you want to replace all the fluorescent lighting in this school, example a school, with LED, you have to spend 10% more on the construction stage. By spending that, you can save about 36% after 30 years of running this building, and 40% after 60 years of running the building. How does it work for PV? Going for free PV, you can save to some extent, but we might not be able to meet the construction 2025 target. So we are looking at the paying for PV option, by which you can save about 17% after 40 years of running the building. The blue bar shows the life cycle cost of M&E services for the school. Lighting is 37% of these costs. As you remember, by replacing fluorescent with LED, we could save 40% on lighting. This saving, 40% saving in lighting, means 18% saving in the total M&E components of this school. And we could save 17% by buying PV solar panels, which is 15% of the total cost of M&E services in this school. Therefore, we could achieve the 33% reduction required by construction 2025. Okay, as I mentioned, you might ask when the cost we spend, the capital cost we spend will be recovered. We did the payback time analysis to answer this question. your LED cost will be recovered after before year 4, and you might say, we don't want to pay for our PV, so how does it work? If you pay for your PV, the costs will be recovered between year 6 and 7, and if you decide not to pay for your PV, you should wait until year 15, then you can start saving more compared to paying for your PV option. Construction 2025 was not just about the cost, it was about faster delivery as well. So for this service, we are developing the life cycle cost dashboard in BCM, by which we can do the analysis faster, and also it will help the client to evaluate their options easier. Again, construction 2025 targets, we are using digital working procedure, BIM, dynamic simulation models, BCM lifecycle cost dashboard, so we can deliver the projects faster. You could see how we saved 33% in the cost of the building, and most of these costs were saved at the operational stage, so we saved some, we could reduce the carbon emission as well. Okay, listening to all these, now you might say, we might consider energy efficient buildings and we might pay for that, but how does it work and how LCC can help us to select the right, to go for the right decisions? So the gray bar shows the capex of the traditional building, the green bar shows how much more you have to spend to make your building energy efficient, and the line shows the OPEX, operational cost, and the payback time is 3 years. But for any cost-saving energy efficiency strategy with a payback time of less than 6 years, you might be able to apply for loans, finance, and implementation support. These funds are available to make the energy efficiency options easier. So first, we help you to find out the payback time of your energy efficient option. If you are qualified, the payback time is less than 6 years, 5 years, then we will help you to decide about the best funding option. Here, the funding option has been shown in orange. So we can help you to move the payback time of your energy efficient option from 3 years to less than a year. So if you are a developer, you can spot the best opportunities to reduce the capital cost and end up with more energy efficient and higher value building. If you are working in social housing, RSL, RP, with lower capital costs, you can achieve fuel poverty targets because your tenants will pay less for energy bills, and we could, of course, reduce the carbon emission and end up with more sustainable and energy efficient buildings. So I'm asking you again, what will you base your decision makings on to make the most benefit out of your investment? Yeah. Thanks for listening.